Exercise 5.9. Prove theorem 5.6. Let XD be a metric space. A set U and X is open in the topology induced by the metric D if and only if, for every point Y in U, there is some delta greater than 0 such that the ball about Y of radius delta with respect to the metric D is contained in this set U. Alright, well, okay, so this is sort of a local criterion for being open in a metric topology. Now, we had theorem 1.9, which sounds very similar. Let X be a set and B be a basis for a topology on X, then U is open in the topology generated by B if and only if for every X in U there exists a basis element B sub X in B such that while that basis element contains X, it's a neighborhood of X and it's contained in this U. Okay. So, really, the thing they're asking us to prove is a special case of theorem 1.9 because we know that the topology induced by D is also the topology induced by the this basis of all the open balls with respect to this metric, right? And so we're trying to prove a set is open in the topology induced by D. That's the same thing as saying in the topology, I should say, generated by this basis. Okay. If and only if, this theorem tells us, for each X or Y, whatever you want to call it, in U, there exists a basis element, which for us is an open ball, right? Exactly one of these things, which contains X, while this ball automatically contains Y because Y is in the center of it, and is contained in U. And that's exactly what our theorem is saying here. So, yeah, it's just a special case of theorem 1.9 for the basis consisting of these open balls with respect to the metric D.